Hello, everybody. My name is Pranav Venugopalji. My EDX profile is capital PV underscore 2507 underscore capital WD9Y. My GitHub profile name is Pranav dash Venugopal, and this was recorded on December 26, 2025. Today, I'm going to walk you through a critical security event that shook the enterprise world late in 2025, the Oracle e-business suit zero-day exploitation. We are going to look at what happened, the technical mechanics of the attack, and most importantly, how we can prevent this in the future. I choose this topic because I wanted to understand how critical infrastructures can be compromised by a single vulnerable component. I also want to highlight the dangerous reality where adversaries discover these flaws weeks before developers can fix them, leaving systems exposed. To understand the severity of this attack, we first need to look at the timeline. This wasn't just a sudden breach, it was a lingering silent threat. On October 2nd, 2025, Oracle released a report stating that threat actors might be exploiting vulnerabilities that were actually patched back in July. The situation was escalated quickly. Just 2 days later, on October 4th, Oracle directed customers to apply emergency patches immediately, reiterating that they need to stay current on updates. But here's the scary part. Investigations revealed that threat actors had been exploiting this vulnerability as a zero day as early as August 9th, 2025. That means for nearly 2 months, attackers were silently exfiltrating significant amounts of data from impacted organizations before the general public was fully aware of the danger. This delay resulted in heavy losses and massive data leakages for targeted companies. Now, I mentioned the term zero day. If you are new to cybersecurity, let's define that. What is a zero day attack? A zero-day attack is a cyber attack that exploits a previously unknown software vulnerability before the developer has had a chance to create and release a patch to fix it. The term zero-day literally refers to the fact that developers had 0 days to address the security flaw before it was used against them. These attacks are incredibly dangerous because the window of exposure can range from a few hours to weeks, or in this case, months before a fix is found. The specific vulnerability we are analyzing is cataloged as CVE 2025-61882. Now, what is CVE 2025-61882? This is a critical flaw affecting the Oracle e-business suite, specifically located in the BI Publisher integration component of the Oracle concurrent processing product. This vulnerability allows for pre-authentication remote code execution. In simple terms, this means unauthenticated attackers, people without a username or password, can take full control of the ERP system just by sending specific HTTP requests. It was discovered independently by security firms like CrowdStrike and Mandiant, which led Oracle to issue those critical updates we discussed earlier. Let's break down how this actually works technically. As you can see this diagram, the attacker starts by writing a malicious script. They inject the script into the website aimed directly at the server. Usually, a server would return an error message to a bad request, but in this case, the malicious script gets executed, granting the attacker access. More on the next slide. So, how did they bypass the security? First, the attacker sends a web request to a public Oracle page that did not require a password. The core of this attack involves XSLT or Extensible Style Sheet Language Transformation. XSLT is essentially a set of instructions that tells a computer take this raw XML data and turn it into a readable web page. Here's the trick. The attackers fool the server into opening a specific type of formatting file. They give the translator, the XSLT processor, a malicious instruction, which essentially said, while you are formatting this text, run this Java command to open the digital log. Because Oracle gave this component too much power, allowing it to execute Java commands, the adversaries took advantage of it, resulting in remote code execution. This sounds devastating, but it was preventable. Here are three specific ways this could have been stopped. First, number one, strict input validation. The code could have been designated as an instruction that says if there's a new line or enter key, reject it immediately. This simple check would have stopped the payload from being smuggled into the system. You can also add a character validation in there to make it even more stronger. Second is secure processing mode. Oracle could have configured the XML parser to disable arbitrary code execution. There is a specific setting in Java for this called feature secure processing. If this switch had been turned on, the server would have simply denied the execution of the hacker's program, and the attack would have failed. Third, enforce authentication everywhere. Finally, the code could have checked for a valid session cookie or username before processing any data. If the user wasn't logged in, the server should have dropped the connection immediately before the malicious code even had a chance to run. In conclusion, this event teaches us a vital lesson about modern cybersecurity. Reactive patching, waiting for a fix and then applying it, is insufficient against campaigns where zero-day exploitation precedes public disclosure by weeks. The attackers were in the system in August, but the emergency patch didn't arrive until October. Security teams must pivot their strategy. We must proactively hunt for silent data exfiltration and malicious database artifacts to detect intrusion before the extortion phase begins. Thank you for watching. This has been my final project for CS50 Cybersecurity.